And this is hey hello good morning guys, and this is Coding with Gautam. And guys, today we will be doing part 3 of our Emotion AI project. So let's begin. So first we're going to be talking about optimizers, then we're going to talk about the check pointer, then we're going to talk about actually training the model and how that works. We're just going to lightly cover the saving and loading of the new weights, and then finally we evaluate the model. So let's dive in. So first we take the optimizer. This line defines an optimizer called Atom using TF Keras Optimizers Atom class. You can check more information at this site, which talks about basically the optimizer Atom. An optimizer is basically an algorithm used during training to update the weights of a model based on the loss function. So basically it learns every time it fails. So then the learning rate is basically the parameter that controls how much the weights are updated in each step. Beta 1 and beta 2 are hyperparameters that influences how the optimizer adapts to the data. And then AMSGRAD is a Boolean flag that controls whether to use a specific optimization technique. So then we compile the model. So basically this line configures the training process for the model, for our basically model. And loss specifies the function used to measure the error. We use mean squared error, which is basically the best way to define error, to find error. Then optimizer is use the specific optimizer we're using, which is the Atom optimizer. The metrics define additional metrics to track, but we want to track accuracy. Okay, then the check pointer. This line creates a checkpoint to save the weights during training. The file path is facial key points weight.keras. Verbose 1 indicates the checkpointing process will be printed into the consoles. Save best only true is that you save the model with the best accuracy. Then the progress bar. So basically this defines, so normally you don't need to do all this. This is some extra code to make sure that you can see the actual progress bars and you can see how much the value of loss has improved. So this defines a custom callback class called TQDM callback to display a progress bar during the training process using the TQDM library. The callback tracks the number of epochs and updates the progress bar accordingly. Then the history. This is the key line here. This line trains the model 1 facial key points, which does the model we're doing, and it trains it on the X train data and Y train data. Remember, the X train data is the X coordinate of the eyes, the Y train data is the Y coordinate of the eyes. So these are these are the 3 things that matter most when creating your model. So basically the batch size specifies the number of samples it's processing each step. The higher the batch size, the more it processes it at once. The epochs defines the number of time you run the whole data through the model. Validation split, it reserves a portion of the training data for validation. So I trained on 97 and put 3% aside. Verbose 0, basically you do not print all the training logs. And then the callbacks, you basically use the check pointer and the callback to make sure that you're updating to get the best model updated, and that you use the TQDM to get the progress bar. You can see that right here, how the progress bar goes up, and after 100 it's fully black. So then the model evaluation, you can play around with these. Basically we're trying to get an accuracy of more than 80. So let's try NX in here on. So here in my notepad, I have all the tests and which have yielded the best responses. We can clearly see that the batch size of 64, epochs of 25, and validation split of 95% has yielded the best accuracy, which is 81.49. You can play around it depending on your system and what software you're using. They can vary on how well your software runs. So for now, let's just use 128 batch size, 20 epochs, and validation split of 0.3. So this is basically just saving the architecture using JSON. You write the JSON file and basically update it for future use. Then you just comment it out because you don't want to keep running it every time. So what happens is you have to rerun the code, all of the code every time you rechange the bat size or the epochs to make sure that you actually generate a new model in a new instance of its running. So that's why I just commented this out. You basically just save the model, then you load the model architecture in, you load the weights with a weights file, basically pre-written weights as your original, then evaluate the model. So model evaluation, so this line basically asks it to evaluate X test and Y test, and then it asks you to print accuracy. And then yeah, so in the second the second index of the accuracy function is the accuracy. So we can see we have a pretty bad accuracy here, 72%, but as I said, play around, find what works best. So let's assume that our best accuracy is 82. So then you get history keys. This is basically retrieves the keys in the history dictionary, which stores information about the training process. So loss value. The loss value is basically your accuracy and how much how much you lost. Then we plot the loss value, then the val loss. So basically how much we lost during trading and then how fast. So after every epoch, how much accuracy we get. So we can see that after the training, after the fifth epoch, we have had no increase, but during the value loss, we have had lots of gradual increase as we have been training the epoch. So the goal is to get less loss. So then the Y is the loss, the X is the epoch, then you just graph it, location is upper right of the index, and then you show. So then you can keep changing this and make sure that at the end, just choose the epoch value, which has the most zeros. So you can choose the epoch 17.5, 25, but definitely not one epoch as the loss is too high in both scenarios. So yeah, this is training your model. Train your model, find the best accuracy you can, and then give it a try. After you have a good accurate model, we can move on to the next video. So this is Coding with Gautam. Thank you guys for watching. Any questions in the comments, or do you need any files, just comment it below. I'll make sure that gets to you. So yeah, thank you guys, and Gautam out.